2. 1 2 1 2. Is this working? I have no idea. It's been such a long time since I've done a live stream that all my OBS settings were returned to default values, and all my USB devices were messed up, and my cameras were all in the wrong positions. So guys, I'm going to need you to tell me how the stream is looking before we get started. Now this is going to be a pretty fun one this evening, I think. Some of you guys like it when we work on kind of more like smaller, jankier kind of stuff. Like I've done a lot of big amplifier repair videos, and this is going to be maybe some really interesting looks at common faults found in the lower budget end of car audio amplifiers. It looks like I'm dropping a lot of frames here, and I think that might be because I have switched to 60 frames a second, which might not have been the best idea. I'm still using my LGA 775 machine from like 2007, and it's now 2020. So how long has this PC lasted me? But yeah, it's doing alright. I might just knock the bitrate down a touch. If the stream drops out now, you know why. Sometimes it doesn't like adjusting the bitrate on the fly, so I'm going to knock it down to 5000 kbps. Just bear with me, see if this helps at all. Okay, we're currently sitting at about 5 kbps. I'm not getting any chats, so I have no idea if this is actually working or not. Guys, leave me a comment in the live chat, because I need to know if this is working, and currently I don't have anything in the live chat really, as you can see here. Just give me a shout, let me know how the stream looks, and then we'll get started on some repairs. On my live dashboard it says video output is low. There'll be some teething issues getting back into the stream, guys, so just let me know how it looks. Still no comments? It says stream is offline. I have no idea what's going on. Okay, should be back online now, guys. I have dropped the frame rate to 30 FPS. Teething issues, teething issues. Okay, sweet. How are we looking now? How are we looking now? Okay, I think that's looking better. I have a green little box down the bottom of my OBS screen, which means that the video output is good. I think the issue was that I switched to 60 frames a second. That was a bad idea. Let's go back up to 8000 and let's see if that looks good. So I'm currently sitting at 5k kbps, now I'm at 8k. Yeah, that's looking good. Alright, what's going on, guys? I think we are ready to roll. Teething issues all lined out now. Stream is resumed, 58 watching, and stream health is looking pretty good. Awesome stuff. Okay, I shouldn't have any amplifier in the description right now. I'm pretty sure that 13 BTR X3 is referencing back in the day when I was doing streams last year, and I would always forget to update the current amplifier in the OBS screen. Dropping frames still by the looks of it. I'll iron out those issues later on, but guys, if you say the stream looks good, then I'm going to leave it as it is for now. Oof, dropping big ass frames. 1 minute, dropping big ass frames. No, this is not good. Come on. 5000. You gotta work on 5k. 5000 kbps. Okay, this should be working smooth now. So, this is green. Okay, man, I swear there's teething issues all day long. So these are the amps that I'm currently working on today. If you can see past the greenness, that should fix itself in a moment. There we go. So, I thought that I would do a live stream today with some smaller, more budget-oriented amplifiers. I've done lots of videos and lots of live streams on big amplifiers, big Class D stuff, and I haven't really gone through a lot of smaller stuff. Now, I happen to have a couple of massive boxes full of these plate amplifiers. These are the kinds of amplifiers that you would find on your budget entry-level Walmart spec active subwoofer box for your car. And there's a company that I'm working with at the moment that have sent me like, I don't know, there's got to be at least like 30 or more of these things in a big ass box. So what we're going to do is we're going to look through these and see why these have all failed. And I'll spoil the surprise a little bit. I've done about 6 or 7 of these in the past a few weeks ago, and the issues that they have are all quite interesting, and they are all different. It's not like every amp has pretty much the same problem. There are different issues with these. And it kind of doing these actually helps learn some more problem solving, because they're usually stupid issues like cracked solder joint or like just really random stuff like that. And it kind of makes you look around a bit more rather than just looking for bad components. You're looking at, do I have the correct voltages on this part of the board or do not? Why is there no audio? You know, if I hold this in a certain angle, does the audio come back, etc. So that's the kind of stuff that we're going to be looking at. Stream keeps switching to intro or infinity amp video. I haven't done an infinity amp video. What the heck? So I'm just checking that the stream is healthy. Has the stream been healthy all the while I've been talking about this? Yeah? Yeah? This is like the first stream of 2020. There's going to be teething issues. Lots of random skips in the video sometimes when you're speaking. Try lowering the bitrate a bit. No, because what the hell? I used to run this bitrate at like 6.5K, right? And I have updated my GPU to a much better GPU now. And I'm using NVIDIA NVENC, which should be like taking the strain off my CPU, so it should be capable of doing this. I'm a bit confused why there's skips and stuff. Seth! Maybe you should keep doing the live videos and then you would not have these problems. Man's on the money right there, Seth. I tell you what, definitely some more live streams coming your way this year, starting from now. It's taken me a little while to get all this set back up again because I'd all pulled it all out, the cameras and stuff. So yeah, now that this is up and running, this live stream is going to be a little bit of fun with these stank-ass tiny plate amplifiers, and we're going to sort out the stream teething issues. So if you guys are looking for a nice quick stream like on some repair tips, then maybe wait till the next one. But this one is just going to be looking at some interesting small problems, troubleshooting tips and stuff on these amplifiers while we work out the stream issues. But thank you very much, Seth, for the US 5. That is my man. And we've got some old school guys in the chat. Yeah, okay. So, provided the stream looks alright, I'm going to crack on and get started on some of these plate amplifiers. And if there is a noticeable issue with the stream, then just spam me in the chat and I'll try and get it fixed. If everyone is experiencing the skipping issues with the video, then let me know and I'll try and figure out what the jam is with that, because I haven't had that before. Usually the issues with the stream have just been like cutting out randomly. Okay, so let's take it to this camera. Oh yeah. So these amplifiers are plate amplifiers, as I said before, and they are mono plate amplifiers for a subwoofer enclosure, active subwoofer enclosure, single or twin. So as you can see here, this is the Bassface Bass Face Power 12.2, and this is a Class D active subwoofer. So this is going to be a Class D amplifier, and we already know that because we have output inductor. This Jancast discrete drive circuit here. This is the driver board right here. So we're used to, in the bigger Class D amplifiers, seeing the driver board with a drive IC, a couple of drive ICs, PWM generation IC like TL072Cs, and then we have the RS2844S or the 2010S, etc. But this Class D amplifier is a much older design, and it just uses discrete transistors and stuff to basically as the Class D generation and drive circuit. So this driver board right here is what is directly driving the output MOSFETs, which are along here, which there are not many of. I think they're 640Ns. Power supply is pretty simple as well. We've got the TL494 chip, which is TL494 chip down here, which is the same as in pretty much 99% of car amplifiers. This is driving some MOSFETs over here. Power supply MOSFETs, which are in this case 75N06. and then the transformer is here. Now the issues that I have come across on these amplifiers before have been stupid stuff, like I said, cracked solder joints, or just blown power supply FETs, probably from being in Clip City and overheating. I didn't come across too many blown output FETs, and vibration damage. These driver boards on the output section are very wobbly, like they're not held in, so they snap their legs quite often. Other issues we've had on the preamp board over here with the RCAs, etc. So what I'm going to do is I'm going to just take the first amplifier here, plug it in, and see what we have, what we've got going on. Take my multimeter. So the first thing that you want to check when you get an amplifier in is we want to see whether there's any dead MOSFETs before we power it up, because there's no point trying to power up the amp if the FETs are down. So I'm going to spin this round so you can see what's on the screen here. Got my multimeter on continuity mode, which beeps when there is a direct short under about 50 ohms. Just going to go ahead and place this on the power supply FETs, which are the ones directly connected to the 12 volt input over here on the drain. In this case, looks like there's not, maybe because it blew the fuse. Let's take a quick look at this fuse. If the power supply FETs are blown, then most likely this 20 amp or 30 amp fuse will be dead, in which case we'll need to replace that before we start powering it up. Nope, fuse looks good. Alright, maybe I just wasn't pushing hard enough with my probes. But the first thing you want to do is just check you don't have any shorts on the power supply FET. So let's see. Number one amplifier, do we have a short on the power supply FET? We don't seem to have a short. We don't seem to have, oh no, there we go, got a reading between gate and source, between drain and source, and between gate and drain. So the power supply FET, that one, and this one appears to be okay. Charging capacitors there. Cool, so the two power supply FETs, yes, this amplifier only uses two power supply FETs. See that? These two right here. So we have the transformer, we have power supply FET 0 degrees, we have power supply FET 180 degrees. So that is pushing and pulling this baby transformer right here. So the power supply FETs are okay. So I am safe in this instance to go ahead and connect up my power supply wires. But before we do that, let's just check that we don't have any dead output FETs. I didn't see many dead output FETs in these amplifiers before when I was working on them, but we could have them this time. Let's whack that over here. IRF 640N is the output FETs used in these. Really basic stuff. Been around, this circuit design is like ancient. This is like back in the 90s. This is like your original old school Soundstream type stuff. Yeah, no, this doesn't have any dead output FETs either. So this amplifier is looking pretty good so far. No dead power supply FETs, no dead output FETs. So if there is a problem with this amplifier, it will be like a cracked solder joint or something. So, without further ado, let's plug in some power wires and see what the actual problem with this is. Some of these amplifiers might actually be fine. From the batch that I did a few weeks ago like this, these little plate amplifiers, a few of them just didn't have any faults whatsoever. And that's actually surprisingly common working as an amplifier repair tech, especially with car audio, where it's not necessarily always the amplifier that can cause what looks like an amplifier issue, like wiring problems or subwoofer issues. Quite a surprising number of the amps that I get in to be repaired or serviced actually are completely fine, and it turns out to be something silly the customer's doing, or some other issue in the vehicle. Alright then. So we should have, I'm just going to make these a little bit bigger. These little, just going to make these a little bit bigger over here. So this screen, if you're new to the streams, this little screen over here is going to be our voltage and current reading. So as you can see here, we have 12.3 volts, and this is 0 amps at the moment. Hopefully you guys can see that. If you're watching on a nice big screen on 1080p, you should be able to see that. And it is a little bit bigger there on my scope screen. And then yeah, this is the scope screen. And so what we're going to do is take my probe here, and I'm going to go ahead and probe the power supply MOSFET drain, which is the second pin. So on the MOSFET, you have 3 legs, and you'll have number 1 leg reading from left to right is the gate. This is kind of like the activation switch. There'll be a little wave on there turning the FET on and off. Then pin number 2 is the drain. This is the output of the FET in this case. And pin number 3 is source, in this case ground. So I'm just going to go ahead and put my oscilloscope probe on the drain here, which I'm going to just use the back of the FET up here. Now, as you can see on my scope here, the line jumps up to about 12 volts, 12.25 volts there. So let's zoom in a little bit on the scope, reject high frequency. And just for the first power up, I always like to run the voltage down a bit lower, about 10.8. If there are any issues with the amplifier, like bad drive circuit for example, a lower input voltage will transpire to a lower rail voltage, which can help protect and save damage to any of the components if there is an issue. So I'm going to go ahead and hit the remote, turn the amplifier on, and see where the problem lies, if there is one. And we should see a nice big square wave on the screen here if this comes on. Whoop, there we go. So there's a nice big square wave on the power supply, FET on the drain. So the power supply is active. We have a green light on the amplifier, just over here somewhere. Get used to the camera. There's a green light. So the question is, are the output MOSFETs switching? So these four 640N MOSFETs should have a big square wave on them as well, similar to the power supply but at a slightly higher frequency. As you can see, we're only drawing 0.3 of an amp. These are usually quite efficient on idle, they don't draw much idle current. So this one is a high side FET because we are probing the drain of the output MOSFET, and that has high rail voltage on it, about 30 volts. This one should also be high, and this one will be low side. Aha! Look at that bad boy. So on a high side FET on the output section, we should have positive rail voltage, and the low side FET should have a big square wave that looks a bit like that but just higher amplitude. In this case we have nothing, well we have -2 volts, so that's not good. So there's going to be a drive circuit fault here with this amplifier. I'm just going to turn the amplifier off and turn it back on again and see if we get any little glitches or hints at the amplifier trying to power up. Nope, it looks like the drain of the output FET just sinks down to 2.7 volts, so that's not good. So the first thing that I'm going to do in this case, because I've seen these amplifiers before, these output driver cards, they tend to sometimes snap the legs because they're not seated in very well, they're wobbly as hell. So what I'm going to do is I'm actually going to power it up again whilst holding the driver card at different angles to see whether the output section comes to life, and in some cases that has worked. So let's probe the low side drain again. I'm just going to push the driver board forward first and see whether the amplifier comes to life. Nope, still got -2.4 volts down there. Now let's try knocking it back. Okay, same again. I'm just gonna, while it's turned on, give it a wobble. So it doesn't look like we have any any snapped leads on this driver board. So I am going to go ahead and guess that there is a issue then on the driver board itself. Bad component in there. Either that, or the driver board isn't receiving all of the sufficient voltages needed in order to work. And one of the things that can cause that is no negative rail voltage. So what I'm going to go ahead and do now is confirm that we have both positive and negative rail voltages getting to the output section. So we clearly have positive rail voltage because that's this one here, plus 30 volts, and we should also have the negative rail voltage, and that should be on the source and gate of the low side FET. So if I go down here and check the source of the low side FET, yeah, we've got -36 volts. The rails are very far apart. Let me just go ahead and show you that on the scope screen right there. So on the positive rail we have 30.75 volts, and on the negative rail we have 36 volts. Now these amplifiers are cheaply made, and it wouldn't surprise me if that was normal, to be honest, but it could be an issue. So next thing that I'm going to do, next thing that I always do when I see things like this, is I am going to inject the amplifier with some RCA signal. And what that does is it forces the output section to try and oscillate. And I'm going to see whether we get any glitching or any kind of attempts at building output drive. and if so, that tells me some things about the drive circuit, and if not, it tells me other things about the drive circuit. So let's take my RCA lead here and shove it in the RCA input. Stick the remote wire back in. And power her up again, this time with RCA signal going in. We've got 48 volts going in, and we've got about a peak-to-peak signal wave of 1.4 volts. So let's probe that bad boy again, see what we get on the screen. Whoa! Aha! Did you see that? So let me take you to the scope screen again. It attempts to switch. There is output switching there with an RCA signal present, which isn't there when we take the RCA out. Let's remove the RCA. Let's do it one more time. Just going to go ahead and remove the RCA signal, power it up again. As you can see, there's nothing there. Doesn't want to come on. Give her some RCA signal. This time I'm going to lower the amplitude of the RCA input signal because it looked like it was quite high. I'm just going to see if that helps it stay on. Woof, okay. Yeah, so it comes on, but as you can see, if we look at the current here on my power supply, 0.3 was the idle current that this is supposed to be drawing. And when we feed it with RCA signal to force output switch, it's drawing, well, over 2 amps, as you can see there. I've got my current limit set at 2.6 amps there, and when it activates and comes on, it's drawing over 2 amps, so that's not good news for this little amplifier. So either we have a drive circuit fault, which is possible, or the drive circuit is fine and it could be an output inductor short on the windings of the output inductor just here. If this is shorted or disconnected, dislodged from the bottom, then it won't complete the feedback loop. Potentially it could be using this as part of the feedback loop, and that's why it won't idle switching. And it's also why when you try and feed it with some signal that it tries to draw a bunch of current. Just to confirm whether the inductor is shorted or not, I'm going to go ahead and probe the speaker outputs. Now, if the speaker output has the same square wave on it, like that as the low side drain, then that shows us that the inductor is probably shorted, therefore it's not actually filtering that high frequency switch wave and leaving us with the sine wave, it's just letting it pass, which would cause the output section to draw excessive current. So let's just see whether that is the case. So as you can see, I'm probing the speaker positive output here. Still got my RCA signal going in. Okay, no, so the inductor is filtering that. I don't know if you can see that on the scope screen there. Inductor is filtering. We got the sine wave there and no big square. So that leaves us then with this issue being a drive circuit fault. Let's look at some live chat while we... So now we've worked out what the issue is with this amplifier. Now this is actually quite strange because, I'll tell you why. When I did about 6 or 7 of these a few weeks ago, I didn't actually come across any that had output drive circuit faults as such. It was just always snapped legs or something easy like that. Whereas this one appears to, or what we'll find out, appears to have an actual fault with the output drive circuit. One last test I'm going to do just before I go ahead and jump on some live chat and reply to some of you guys, is I'm going to try that technique where I hold the driver board at different angles like this while my RCA signal is going in, because sometimes the amplifier doesn't want to idle anyway. I'm just going to see if it makes any difference to the current draw here. So let's just knock that down to about 2 amps. About 1.6. Let's go up to 2 amps. I'm going to only let 2 amps pass. 10.7 volts going in. Let's see if pushing this helps, and that will tell us whether it's a snap lead, because I'm surprised if it is a drive circuit fault, to be honest. Nope, still drawing a bunch of current, and the wave doesn't look like a particularly nice shape either. Nah, drawing a bunch of current. Okay, no problemo, senoro. Let's just probe the low side gate. I'm curious to see what the low side gate looks like. I'm going to give you my scope screen so we can both look at the low side gate real quick. Whoa, that looks bad! There is actually, doesn't look like there's any low side gate, really, does it? Look, there's nothing. There is, oh no, hang on, my bad, that was probing the source. Stupid ass, you big dummy. I'm nicking that from Big D. Okay, yeah, so there is low side drive, but it has a big ass spike. Look at that. I'm going to go ahead and AC couple the scope so we can zoom right in on that low side drive wave. Boom! That should not be there. Drive circuit fault, my friends. And let's go ahead and do the same for the high side. The high side gate drive will be big, just like the higher voltage. Let's go up to 20 volts. So there isn't an issue with the shape of the wave as such on the high side output, on the high side gate. So it's just a low side gate. So it's a low side gate drive fault on this one. Okay, let's go ahead and look at some chat. Oh, got some light, got some. Here we go. Okay, so we started the video about here. I'm just going to move this camera a little bit. Sam, I have a question for you. I have a subwoofer SP15C XXX 3.5K. More advice on what amp to take between a SKV to whatever that is, or a Triumph Smart 3. I would take the Triumph Smart 3. Very impressed by the results from Big D Wiz. I went through the circuit in great detail, and I think that it is a massive step in the right direction, and the efficiency is off the scale, and also it will give you more perceived power than the 3K. And it's cheap as hell. I would support the movement to full bridge, and I would go for the Triumph Smart 3K, Smart 3. I think it's great. Random enter, yeah. Thanks for the solar tip. I done my refload the whole board and got my channel 2 RCA back. Sweet. Don't remember saying that, but that's sweet. Awesome, nice one, man. Glad you got it back. Have a newer Orion XTR that has 4 visibly burnt MOSFET sound was still coming out. I'm hoping that means the driver board is, as you said, very hard to fix. Yeah, so basically, if you've got visibly burned MOSFETs but the amp still comes on and makes sound, those MOSFETs will be in a power supply section. You'll have multiple transformers in the power supply section, and what's happened is that the MOSFETs have shorted on one transformer, and they've shorted and then gone open, so that they're not presenting a significant resistance to the circuit anymore, because they've just burned open. You know, they've basically broken the circuit. So the amplifier is now only running on a less number transformers than it originally had. If it's got 2, then it's only running on 1 transformer now, which is obviously a massively limited supply to the amplifier. So don't run it like that. You will probably need to change, obviously, those MOSFETs that are visibly burned, and any else that are in parallel with it in the same bank on the same transformer side. And you will also potentially need to change the driver transistors for those MOSFETs that are burned. But yeah, as you say, luckily the output section is fine because it still comes on and makes audio, which it wouldn't do if the output section was bad. So yeah, it should be alright. Should be a nice, easy repair on that one. Chat seemed to be working alright. Video seems to be working alright. Thank you very much to Matthew for Makiva for the £2. Thank you very much, my friend. That will buy me some chicken nuggets and chips. Do you know much about the subwoofer brand Atomic? A little bit. I've not used any Atomic gear myself. A good friend of mine runs some Atomic gear. Seems to be pretty solid. It reminds me of FI a little bit, but like I say, I haven't actually used the brand myself. I haven't had one up close to inspect and look at, but it does remind me a bit of some FI woofers, but they seem pretty solid, man. They seem pretty good. I've repaired an Atomic amplifier. Yeah. Chat seems to be working. You need a fancy power supply that has a digital reading so you can add it to OBS. Same with your multimeter, like Rossmann. Yeah, I have considered doing that. The only thing that really annoys me about things like that. I love my cheap ass multimeter, right? So when I was starting out repairing and stuff, and a lot of people on the streams and stuff have suggested, oh, why don't you use like an expensive, you know, like a Fluke multimeter or something decent multimeter? And the reason is that all of those ones that I have tried and have used, that have belonged to friends or that I've looked at review videos for, I have looked into getting a nice, you know, decent multimeter. What actually is the case is that they have like a delay, right? So with this cheap ass multimeter, when I put it on diode beep mode, okay, it's absolutely instantaneous. The beep comes the second the wires touch, like it's literally just making the circuit. There's no processing involved. The multimeter's not thinking about it. On the Fluke that I have, or on the various Flukes that I have tried that have belonged to various other people and that I've seen online, there is a delay. When you touch the wires, there's maybe like a half-second delay or even longer before the multimeter actually beeps and tells you there's continuity. The same goes for the resistance readings. When you put it onto resistance mode, on these multimeters, I prefer to manually set the resistance band that I want, because then I know, like say if I'm reading a 1000 ohm resistor, then I'm going to put it on that mode and I'm expecting to see a value that fits into this screen. You know, if it's over 1k, then when I read my 1k resistor, it's not going to show anything on the screen, and then I know it's potentially open or high value. Whereas with the auto scaling multimeters, they still show the value, and I've then got to look at the screen and work out what tiny little M or mega or milli or whatever it is present at the time to see what actually is reading. Whereas on this one, I can literally just manually set it to what I'm expecting to read and know that the numbers on the screen are based on the position that I've set it at. I really like that, and it's just quick. It just responds pretty much, you know, it's pretty quick compared to a lot of the ones I've seen, and it's cheap and it just works. And so I would worry that getting a multimeter that is digital as well, that can output to OBS, would be excellent. However, it would pose the issue of potentially having delay and, you know, not being as nice and quick and easy to use as what I like. What I have considered doing though is getting the multimeter and like strapping it onto the bench or the wall, like duct taping it up there and having a camera permanently fixed on it, just like I do with the power supply camera. Just having a camera pointed at it the whole time so you can see what's on the screen. That's probably what I'll do. What FETs and gate resistors do you in place of the 640Ns? So generally I just use 640Ns. There's generally no point replacing those for anything more or anything more powerful, because the drive circuits for those amplifiers using 640Ns tend to be pretty weak. So the 640Ns are hella easy to drive, so you don't really want to be putting anything too low RDS in there. And for gate resistors, they should be, the majority of the time I see they are 10 ohms. 10R gate resistors on a 640N, that's pretty standard procedure. Any updates on the car? Yeah, I'll be doing a video on the car pretty soon. The front stage is pretty much done. T-line doors are in and vinyled and looking and sounding beautiful. Let's have a look. Any build updates? Jesse, how's it going? Good to see you on the stream. It's been a long time. It feels like old times now. I've got a bunch of my old guys on here. I think I missed out a whole bunch of this. Oh wait, here we go. Here, this is where I was. I have a US audio tube amp. It sounds bloody horrible. The tube amplifier is a refined taste. I've enjoyed your amp explanation on Big D's channel. Thank you, my friend. Yeah, it's been really fun doing those. It's been annoying because I've wanted to always have the amps that he's doing on my bench as well to like properly look over them and confirm some of the things that I'm saying. But obviously, you know, shipping and that. It always gets warm. Real Flow says amplifier always gets warm when it's been on for about 30 minutes or more, whether it's been playing music or not. Yeah, if it's one of the new Korean full bridges from like DS18 or Vibe or any of those, they do run warm on idle, and a lot of these new low RDS, small compact full bridge amplifiers, they do run warm on idle, and some poorly designed half bridge Koreans as well, they run warm on idle. So let me know what amplifier it is exactly, Real Flow, and I'll let you know if it's one of those ones or not, or if there's an issue. How's the van going? Van's good. I'm just making some box mods, so the subs are out of the van at the moment, and then I'll go back in. Is it possible to add an O-scope to an amp? Like, yeah, definitely, because you can get those tiny little O-scopes in an MP3 package, so it wouldn't be difficult to just permanently wire one of those up to your amplifier. Easy to do. Yeah, that'd be pretty cool actually, wouldn't it, hey? You can get those pretty cheap as well. Brandon, thank you very much for the 5 US. Watched all of your videos. Oh hell, I hope you ain't watched all of them, because trust me, they go back to like 2006, and some of them ain't good, man. Some of them ain't good. Some questionable videos back in the day on my channel, and that isn't an invitation for you guys to go. What I've been slowly unlisting all of the older videos, well, a lot of the older videos that are just basically nonsense from when I was like in my early teens and stuff, doing nonsense videos on YouTube before YouTube was even really a thing. Can you blow speakers if you run them extremely loud without them moving much? Yeah, for sure, absolutely. The driver excursion is not showing you how hard the woofer is moving. Obviously, as the frequency goes higher, you need directively more power as the frequency goes higher for the same excursion. So let's say you're moving 4 mils and you're playing 100 hertz. To move 4 mils, 100 hertz, and you're clamping, I don't know, 30 watts to the speaker. Okay, to move the same 4 millimeters at 1000 hertz. Instead of clamping 30 watts, you now might have to clamp 300 watts. Just random numbers coming off my head, but it progressively goes higher, the power, as the frequency goes higher for the same excursion. So yes, you can absolutely blow a speaker and not have it visibly moving much. Easy peasy. My amp is a digital amplifier. It's a dual XPR84D. I am not familiar with that amplifier, unfortunately, right now. However, if you send me a message, go to Facebook, type in Bearvids, send me a Bearvids message on Facebook, on my Facebook page, and just tell me the same thing that you just said here, and then later on I'll go ahead and look it up and see whether it should be getting hot or not. Another 5 from Seth, my man. Cheers, Seth. Thank you very much. Quit being hard on yourself, Sam. We love your videos and we miss your lives. Thank you very much. We got a 10 from Matthew. Thank you very much, my friend. Didn't want to include a message with the donation. Very kind of you, my friend. Thank you so much. This is crazy. First live stream of 2020. Got some people being extremely generous already. Thank you very, very much. Okay, let's crack on back with the. I'm sorry if I missed your chat. I don't want this stream just to turn into chatting all night. I want to turn my attention back to this amplifier, and we already found out that the issue appears to be with the drive circuit. The side gate looks bad. So what I'm going to do is I'm going to confirm that the low side gate drive looks the same bad on both FETs, because it could just be a gate resistor potentially that's gone out of tolerance, or one of the legs of the 640Ns has maybe snapped off the back. So I'm going to go ahead and remove the clamps from these FETs just to get a better look at the legs and such. And most of these amps I've actually repaired most of these amplifiers without taking the board out of the heatsink here, because you know they're pretty exposed and you can do top board repair quite easily on this. So first thing I'm going to do is just take the 2 low side FETs here and the high side, just give them a bit of a wiggle, and I want to make sure that there's no snap legs, because that's an obvious issue. Doesn't look like there's any snap leads on these ones. It gives me easier access to them as well for probing. So let's turn the power supply back on, and I'm going to power the amplifier back up with the RCA signal injected, and I want to check out the low side drive wave of both of these and make sure that they are both kind of the same, and that then tells me that it is in fact a drive circuit fault. So let's go ahead and take a look on the scope screen up here, and you'll see the shape of the wave. Okay, yeah, so that one had the big ass spike on it, and let's just check the same for this one. Yep, also has the big ass spike on it. Cool. So my first thing that I'm going to do is I'm going to use my thermal imaging camera. I'm going to remove the RCA signal, okay, because I don't want the amplifier just to be, you know, burning up here. I'm going to remove the RCA signal, and I'm going to go ahead and use my thermal imaging camera to look at the output driver board through it and see if any of these components are visibly getting hot. Because if that will, you know, that's a really easy way to just pinpoint your problem right there. If any of these are out of tolerance and they're getting hot because they're leaking, and you know, then that is a nice easy way to see. Now I don't think that any of them are going to be getting hot because none of them are looking hot so far on the screen right here. Don't know how easy it's going to be to show you this. Oh, there we go. You can kind of maybe see a little bit. So what we're looking for is we're looking for a hot spot on the driver board here. So let's power the amplifier up one more time. And I think I'm going to crank the voltage here up a touch. I'm going to crank it up and see if anything is getting warm. There's a little hot spot at the bottom, perhaps. Can you see that there? It's not very hot, but it is a little bit of a hot spot just at the bottom of the driver card. It's only 26 degrees, but down there we've got a 47 UF cap. But I think the hot spot is just to the left of that, and there is some heat on the legs actually, right down the bottom there. But this thermal imaging camera is not very accurate, so actually the heat's probably coming from the transistors just above it. Mini Mafia sends me a $3.99. Love the channel, subscribed and learning. Thank you very much, my friend. Very, very kind. Thank you so much. I'm glad you're learning. It's what it's all about. This is why I'm doing this stuff, is just to enlighten people a bit more to repair and get people thinking, get people, you know, not scared to try attempting repairing their own stuff. So yeah, there are some hot spots on the driver card right now. They're nothing crazy though. Like, this is going to be just normal operational heat. We've got 30.6 degrees. As you can see, I've got 30.6. Come on, do a focus. 30-point-ish degrees on this hotspot here. If I move this over slightly, 30 degrees, 31, 34. So yeah, nothing really overly like pinpointing me towards where the issue might be. So the next thing that I'm going to do is, I'm thinking the next thing I'm going to do is remove the output FETs entirely, drive an RCA signal into the amplifier to get the output drive circuit, you know, trying to oscillate like it is when I plug the RCA signal in. Then I'm going to go ahead and probe a bunch of the transistors on the driver board at the back here to see whether I can see where the drive shape turns bad, because there might be a point on here where it starts turning bad. I think maybe first I should probably take the amplifier out of the heatsink. Right, now the idea of this live stream video was going to be how many of these things can I repair quickly. So this one here, annoyingly being the first one, has a more in-depth issue than these things usually have. It has a drive circuit issue. So this one, you know, this is a slightly more in-depth repair. I'll be taking it all out, I'll be going through the drive circuit, blah, 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 blah. I was expecting to bang these out like in, you know, an amplifier every 5 minutes or something. So guys, the choice is yours. Would you like to see me dive deeper into this one with a drive circuit fault, or would you like me to put this one to one side and go through a bunch of the other ones that probably have much simpler, easier to fix issues, and you can see the, like, you know, bad solder joints and stuff like that going through? Let me know what you'd like me to do, whether you'd like me to dive into this one with a more in-depth fault, or just put this one to one side and do some easier ones. A couple of guys saying dive deeper. Okay, cool, we're going to keep going on this one. What I will say is that probably already, now this amplifier isn't worth sod all really. Like, no one's going to buy this. And to the company who make these bass face, they're very, very cheap to manufacture. So by having a drive circuit issue, this is probably already like too much damage really to be worth repairing. So on a normal situation, I would write this one off, because by the time that I have gone into the drive circuit and worked out what's wrong, the repair bill will cost more than this amplifier even costs to produce in the first place. However, for you guys, we should do it. Matthew says £2. Thank you, my friend, and your skills still skipping and jumping. What can I do? Can other people confirm if I'm still skipping and jumping? And I will just see if I can adjust the settings a little bit, maybe. Output settings, what we got? NVIDIA NVENC. We've got 5000 kbps, and we've got performance high. I'm going to switch to baseline. I'm going to go for low latency, max performance. Max quality, max performance. Okay, I'm gonna go ahead and change my profile to baseline in my graphic settings, and I'm going to change my preset from performance to max performance. Let's see if that helps out at all. Jumping for a few people. Okay, I'm just going to change it up. Just change the settings, so let's see how that goes. Alright, let's get to cracking this thing out of the heatsink then. Fortunately, these things aren't they take too long to get out of the heatsink. Got a few screws around here. A few screws holding the board down. Power supply, MOSFET clamps, bye bye. Wyatt Sound Lab says what MOSFETs and gate resistors do you use in place of 640N? So I did answer that earlier from your previous question, but I'll say it again. There's no point replacing 640Ns with anything else because the drive circuits for them amplifiers are usually pretty weak. And you know, there's not really much point of doing that. You're not going to make the amplifier do any more power by replacing the 640Ns by anything. They're easy to drive and there's enough spaces in them to do their rated power on those amplifiers. So just stick with the 640N, and you need 10 ohm gate resistors for most of those. Okay, are all the screws out? I think all the screws are out of this one. Let's have a look. 1, 2, 3. Up, one more over here. 13 BTR X3 shoots me over a 20 bucks. Jesus, man. Thank you very much. What have you said? For your troubles, really miss the streams. Have a cold one on me, my friend. Cheers to you. Thank you very, very much. I shall indeed. And honestly, the generosity is crazy. So that's awesome. It's really making me massively motivated to continue with these streams. So yeah, expect to see a lot more streams coming your way. It will always be in the evening time in the UK. So UK time, it will be somewhere between like 9 PM and like 11 PM start stream time, and I'll probably stream till about 1 AM at the latest. I don't want to be doing, back in the day I was streaming till like 4 or 5 AM and that was getting a bit crazy, so I probably won't be doing that anymore. But hopefully the evening stream time in the UK works well with you guys wherever you are in the world, in the States, etc. And if there are some guys that the timing doesn't work out well for, I will try and do the occasional stream in the daytime to try and catch some of you guys in other parts of the world where a UK evening time stream just doesn't really work. Yeah, this board is also glued down as well as screwed down, so I'm just kind of loosening up the glues here, and away she comes. Let's get our first look at the bottom of this PCB, and this will also maybe give us any clues as to whether there are any. It's a bit janky, I'm not going to lie, it is a bit janky, but in all honesty I think that is just, you know, flux and stuff from the factory. Like, this is the power supply FET area, and this actually, like, you know, power supply is working fine, so this is just a whole bunch of flux from the factory. That's not the problem there. Output FETs area we got over here, when this does a focus. When this does a focus, there we go. Yeah, again, a whole bunch of flux, but no major issues there. The output driver card is on these pins down here. I'm going to give it a wiggle and just look visually to see if there are any signs. Nope. Okay, that one looks alright. So there's no any bad pins there. So okay, the back of the PCB looks alright. So now let's turn our attention to the driver board itself. Like I said, I think what my attack on this amplifier is going to be is to remove all the outputs and probe the wave shape as it's going through the drive circuit before it gets to low side drive. I think that's probably my best bet. Another way I could do it is I could limit the current on my power supply, keep turning the amplifier on and measure the waves on the drive circuit here while the amplifier is actually trying to switch the FETs. That might also work, but I don't want to keep stressing the amplifier unnecessarily. There is a capacitor here that looks a bit janky. I'm just going to try and get this nice and close for you right here. If I turn the light off, maybe that will be easier. So there is actually a capacitor here that looks a bit rusted or something. This doesn't look too healthy, this one here, C4. I don't know if that's just like spilled flux or whether that's gone a bit rusty or vented a touch, maybe. It doesn't look too nice either way, but often these issues aren't to do with the caps. Let's just put a multimeter probe across that capacitor and see what it reads. You can't really measure capacitors with the multimeter, but I just want to see whether there's a a short or like a low resistance there perhaps. So it's charged one way round and we should get a little beep and charge the other way. Yeah, I mean the capacitor, it's not like overly leaking anything, so I'm going to leave that for now. And I'm going to go ahead and first of all, I think possibly the first thing that I want to do, just before I remove the output FETs, I'm going to take my multimeter. I'm actually just going to go ahead and quickly probe some of these output driver transistors. Now the sorts of numbers you're looking for when you're probing output drive transistors on these boards, usually they'll read between like 400 and 600 on the multimeter screen with the probes various ways around. So I'm going to look for common values. So there are multiple transistors on this board that are the same, and you'll want to be looking for similar values. And if you see a obviously low resistance with any of these, then that's possibly going to be an issue. So as we can see on this one, we've got 597. So I'm going to go ahead and check the next one here. That's similar enough. It's not too far off. And this one might be a PNP instead of an NPN. 595. So I'm just looking for like obviously low resistances, like sort of 60 ohms or something. Sometimes you'll get a drive transistor that will just go really low resistance, and that will cause these kinds of issues. It's just a little check you can do at first before you start taking things out of the board. That one seems alright. Ah, hang on a minute, what have we got here? What do we have here? Oh, I thought I had a short there, but I think my multimeter was just slipping slightly. $531. That's climbing a capacitor. That's probably going to be alright. That's probably going to be alright. I'm just looking for really low impedances, like under 100 ohms. That's like a telltale sign. Okay, let's remove the FETs and have a look at what the drive wave looks like. There is another cheaty kind of way that I could repair this amplifier. Because I've got a whole box of these, the chances are that there will be one of the amplifiers in the box here that has a perfectly functioning output section. So what I could do is I could take the drive circuit from one that has a perfectly functioning output section, put it in this one, and see if it then works. That will then tell me that the issue is actually on the driver card and not, somewhere else. last thing that I'm going to do, just before I remove the FETs, I just thought maybe the inductor is shorted. So I'm just going to power it up one last time and wiggle the inductor around to see if that changes the current draw from the amplifier. That's a good test to do that I forgot about. So now the clamps are removed from the MOSFET, so I can clip my oscilloscope probe right here onto the low side drain. There we are. Change my scope settings a little bit. Okay, so power up. Ah, remove the RCA wire. Stupid ass. Back in there you go. Okay, no, it seems to actually be a component failure rather than like a physical failure. Alright, so let's remove the FETs then and get to probing the low side drive with the FETs out. Yep, voltage has disappeared, just making sure all the rail voltages have disappeared. Sweet. What have we got in the old live chat? Ah, got some stuff. What's the red glare on the scope screen? It is the light behind me. See this light here? It's reflecting off of the scope screen and the camera. Not much I can do about it, I'm afraid, other than like block out that light, which isn't ideal. Yeah, that cap is stanky, but surprisingly, I don't think that's the issue. I honestly don't think that's the issue. Just from experiences doing these, I don't think that's the issue. Not Calder, but I killed up my Denon CD player while plugging in my iPhone 6 with a... Ah, crap. Damn, that sucks. What's the best way to get rid of amp turn on thump? Check if it does it without your RCAs plugged in. If it still does it without your RCAs plugged in, then there's a whole bunch of reasons actually that it could be thumping when you turn it on. Could be drive circuit related, could be relay circuit enable, could be filter capacitors, could be lots of things. Depends on what the amplifier is. If it's a class AB, then it will be something to do with how the rails are generating. But and thank you very much for the 10, my man, Elliot. That's very, very kind of you. And my heart hurts for you, man. That sucks. When you're using a cheap cable and you trust it, you're like, nah, this will be right. And then it's not, and it kills your expensive stuff. That real sucks. Do you have any luck replacing the 4242 FETs? I replaced those FETs, which are now discontinued, with 59N30. I think they're FQP or FDA 59N30, and they seem to work okay, but the drive circuit for the amplifier that I put them in is shit, sorry. But yeah, they seem to be okay so far. 59N30 to replace the 4242s. Yeah, most of the 4242s you can get off eBay are fakes. They're discontinued parts, so don't bother trying to get them anywhere. You could use 4868, IRFP 4868, but I don't like those FETs. They don't like being run in parallel with each other. They're proper fussy. What's the best camera view for this? Probably that one. Just load her up with some fresh solder. Now, annoyingly, I think there is actually some glue that seeped onto the top of the board where the FETs are, so not only have I got a... Yeah, because look, even though all the solder's melted, it's not pulling out easily, which it would usually do at this point, because I think there's a whole bunch of glue on the top of the board. Yeah, there's a whole bunch of glue on the top of the board. That's a pain in ass. Let's just keep pulling. These are 640N FETs. They're like, you can get like 1,000 for about £1.50. So it's tempting just to cut the legs off and replace them anyway. Come on. Damn this glue, man. Yeah, you know what? Let's just replace them anyway. I'm just going to cut them out. I can't be bothered. Cannot be bothered. They're old and janky anyway, probably. Bye-bye. 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 Alright, cool. It's powered up again, and let's plug some RCA signal in at the same time. Let's see where the drive goes bad. This sometimes works in finding the fault, and it sometimes doesn't. So it'll be interesting to see whether, by removing the FETs, to see what the drive wave actually ends up looking like. See if it ends up looking good or not, because it might look good with the FETs out. It could actually be that one of the FETs was like on its way out. That is also a possibility. So yeah, power supply back on. We're going to be looking at the low side drive. The low side drive wave is an important one. Most of these amplifiers, they will not oscillate any drive wave on the high side FET location when the FETs are out, because it uses the drain of the low side switching to generate something for the high side gate. So usually you won't see anything on most amplifiers on the high side gate with the FETs out. What do we have here then? Let's go for the low side gate. Yep, there's a something there. There's a something. You can see it's doing a little glitch. Let's turn the gain up a bit. There we go. Okay. Alright then. Here is our low side drive, which actually kind of looks alright. You can see the dead time changing there as I increase the gain. I'm increasing the gain of the signal, and you can see the dead time there changing. I'm curious, let's see whether anything happens on the high side. Whoa, this amplifier does oscillate the high side as well. Interesting. Very curious. Doesn't usually happen. However, there is a bit of DC there. Now the high side gate shouldn't have any DC on it. I'm just going to DC couple my scope back again. Oof! Big oof! That is not what it should look like. So guys, just to confirm, if you're not into amplifier repair, okay, let me give you the scope screen for this. I think we've just found the problem. So the low side FETs. So in an amplifier, you have class D, you have low side FETs and high side FETs. Okay. On the low side FETs, you have on the gate negative rail with a drive wave on it, and then this, fucking yeah, that's the problem. Look, and then on the drain, you'll have nothing. You should have nothing, and on the source, you should have negative rail. So in this amplifier, in this case, we've got negative rail with a drive wave. That looks good on the low side. On the drain, we've got some voltage. We've got 14 volts. That should not be there. That should be a 0. And then we've got negative rail. On the high side, it is rare to get oscillation, I'm not going to lie. So we have some oscillation, and that is sitting on 14, well, it's actually sitting on about 16, about 14 volts DC. And then we've got high rail on pin 2, which should be there. And then on the source, we have got 14 volts. So that, my friends, is our issue. It looks like our problem is that we have 14 volts DC on the high side source. So what I could do is, at this point, I could go probing through the drive circuit to try and find where our 14 volts worth of DC is coming from on the high side source. However, I think that will take longer. There is potentially a cheeky quick way to find where that DC is coming from, and I think the way to find where that DC is coming from would be to ground. Okay, to ground the high side source pin, this one here, where there is DC that there shouldn't be. There's 14 volts that shouldn't be here. If I send that 14 volts to ground, then whichever component is leaking and causing that to be there should get hot, and therefore I can pinpoint it with my thermal imaging camera, remove it, replace it, and it's good to go. That will only work if that 14 volts has any decent current behind it. I could just ground that pin and it goes to ground and the amplifier still has a problem because, you know, the leak is very tiny. If the leak is very, very tiny, then that won't actually help me because it won't get hot. I need the leak to be considerable for that to actually help me. Interesting. Very interesting. Right. I'm going to do this again. So the amplifier doesn't see. So this is interesting. I'm going to give you back to my scope screen. So I'm going to probe the high side. I'm going to probe the high side gate. So the high side gate, like I said, shouldn't have any DC on it. Okay. I'm going to turn my RCA signal off, so there's no signal going into the amplifier. And I'm going to power her up and show you what it looks like on the scope screen. So we've got nothing there at the moment. Still got nothing. So a tiny little bit of DC has just popped up on there. As soon as I apply my signal, as soon as the wave appears, the DC goes up. If I remove my signal again, you can see the DC falls. So the DC is only present when there is drive, which explains why the amplifier was only drawing current when I applied a signal. And if I keep bringing this signal level up, you can see the voltage actually on the DC voltage here that shouldn't be here keeps rising and rising and rising. It's going to hit rail voltage in a minute. There you go. Now it's hit about 40 volts, which is pretty much where the rail voltage is at. So yeah, that's that, my friends, is the problem. El problema está aquí. Now, unfortunately, when I do that, the component isn't going to be getting hot because the amp's still only drawing 0.3 of an amp. So what I am going to do is I am going to go ahead and I think I'm going to ground the high side source, which is where the voltage is appearing. And if I take my tweezers here, the high side source is going to be this baby right here, pin number 3 of the high side. So I'm going to send that to ground and we're going to see if anything gets hot on the driver board. And for that I need like a little spare piece of wire. Should have something floating around in here somewhere. There we go, a few spare bits of wire for this exact purpose. Now, do I send it to the output ground or do I send it to the main power supply ground? Let's see if they're connected. So on an amplifier, on a car amplifier, there's 2 separate grounds. You have the battery ground, which is the one you connect your ground cable to from the battery, and then there's a speaker output ground, which is going to be the negative terminal on the speaker outputs. Now, some amplifiers have this just directly connected to the main ground, but some of amplifiers have it floating and some of them have it connected via like a 1000 ohm resistor, etc. So I'm just going to see what the case is here, whether these 2 grounds are connected to each other or not, and that changes which ground I can use for this little experiment. So ground over here, and speaker ground is this one. So in this case it appears that they are connected by a capacitor, because we had continuity when I first touched, but now nothing. So yeah, what I'm going to do is I'm going to go ahead and connect the high side source to output ground. I think that will be the right way to do it. So look on the live chat just real quick. Anything going on? Do you have any experience with DC audio monoblock amps? Yeah, DC audio monoblock amps are pretty much the same as every other Korean half-bridge amplifier. So yeah, quad IRS 21844S output driver board. You'll have like 24N 40F output FETs in anything bigger than a 5K. 064N power supply FETs. Yeah, all the same kind of stuff. Have you ever restored a Nicholas J says, have you ever restored a MBD 3001 that was broken? Not that exact amplifier, but I imagine that 3000 watt amplifier will share its PCB with many amps that I have actually worked on. Big oof! Big oof! Is a 064N MOSFET any good? Define any good. Like, a MOSFET is only as good as the purpose for which it fulfills. Like, it's not a particularly crazy high current MOSFET. It's high enough, but by today's standards, it's not like, oh my god, that's a high spicy MOSFET. You know, it's not like crazy, but it's fairly reliable. Well, maybe not. It's alright. Depends what you're using it for. Like, you know, it's like saying, oh, is a, I don't know. I'm trying to think of an analogy here. Yeah, it's really. Oh, actually, I've got a spare wire on here already. I was trying to solder a wire to this, but look, I've got a wire connected to the ground already, so I can just go ahead and just connect this straight up, and that might actually. It might make some flames, so it might actually do the job that I'm looking for. So I'm just going to apply some fresh solder to the source pin here. So this should be at ground anyway. So if the amplifier was working correctly, by grounding the high side source, this shouldn't do anything. Why is this not showing up? There we go. Yeah, by grounding the high side source, this shouldn't actually cause any issues on a fully functional amplifier because it's already going to be at ground with no MOSFETs in. Obviously, if you had MOSFETs in, that would be an issue because obviously there's going to be a square wave here. But with no MOSFETs in, grounding the high side source shouldn't cause a problem. But with an amplifier that does have an issue, I think this might show us the problem. So let's take a quick look at the driver board right here. So this is where I'm going to be looking for components getting hot and spicy. Take a look with my thermal imager right here, see what we've got going on. Can I show you the thermal imaging camera like I did before? Yep, I can. Alright, and I'm going to go ahead and I'm going to take my oscilloscope probe real quick. I'm going to attach this to... What shall I attach this to? I'll attach this to the high side gate, okay? That will help. That will help. Okay, get in focus. This is very hard to do. Let's turn the light off on this. There we go, that's a bit easier. So I'm looking for this one. There we go. Okay, that's nicely in focus now. So let's, moment of truth then, let's turn it on and see what happens. Ooh! Wait, what the frick? Oh, no. Times 10, there we go. Okay, there we go. So on the scope screen, I'm not sure if you can see that, but on the scope screen there we have our drive wave and it's not got any DC on it anymore. See that? See that little square on the scope? That's not got any DC on it anymore. So I'm going to go ahead and turn the sine wave amplitude up higher. Something's getting a bit hot. We've got 29 degrees. 20's not getting overly hot. Oh, no, we've got something getting to 40 degrees. Yeah, I'm actually adjusting the gain right now. I'm adjusting the gain on the signal generator. So at the moment, I don't know if you can see here. So at the bottom here, we've got max temperature. We've got 41 degrees. So I think as I turn my signal generator up higher, I'm turning it up high now. Does that temperature get higher with more signal? Please? No? I thought it was, but it's sticking around a 40 degree mark. Let's inject some higher voltage into the amplifier. You can see I've got 12.5 volts going in now. I'm going to crank that up just a touch. I'm going to go for higher voltage to try and get some more heat into these possibly bad components. Still got the old 40 degrees. $42.9. Okay, I don't think higher voltage is causing it to get any hotter. I'm just going to go ahead and scoot around here and take a little look myself. I just want to see if I can pinpoint where the hot spots are. So we have got, okay, so we've got 47 degrees now, and those look to be the main drivers down the bottom there. And there is one little hot one actually coming up the top. Okay, so fortunately, okay, so this test hasn't pinpointed us one MOSFET, one transistor that's getting like crazy hot at 80 degrees, which I hoped it might do, but it hasn't. So this output driver card, it doesn't have like 1,000 transistors on it. So what we could quite easily do, and it wouldn't take too long, would be just to replace some of these transistors like one by one, and then we will hit gold. Eventually we'll hit gold. There's only like 4 or 5 like of these transistors down the bottom that get to about 40 degrees, and there's one up on the top left hand side that was getting a bit hotter than the rest. So I'm thinking that we just brute force it. So by brute force repair, you just change parts randomly, like in a small area that you think the issue is, and you will strike gold. So I think that's what we might be doing. First of all, let's remove that short to ground that I made before I forget that it's there and cause more issues. Now, the problem with these style of Class D discrete driven amplifiers, the problem with these is that they are very, very fussy with the transistors on these driver boards. So what you see here on this driver card is kind of the same thing that happens inside one of these IRS 21844S chips. Oh, I just dropped that chip. So these chips basically have similar to what's going on this driver card, but just inside here, kind of. So obviously, being integrated into a chip, all of the batches and all of the tolerances and stuff of the transistors inside this IC are going to be the same because of the way it was manufactured, right? But this discrete driver card, if you change like a couple of these transistors out for like new ones that have slightly different characteristics or tolerances, then it can throw the whole thing off and it doesn't work properly, it draws current, the drive waves look bad, etc. So really it's not ideal to just be changing these transistors out for new ones and leaving all the rest of them the same. Now, like I said earlier, fortunately I have a whole box somewhere. Where's my arm? Here it is. I have 2 whole boxes full of these that I can go ahead and nick some transistors from to confirm the issue. I can fix the problem with the transistors from another one of these boards, and then once I know the transistor that was the problem, I can then replace it with a new one or some new ones, the same batch on the driver card, and then that will And then if that one works fine, then that's fine. But if it doesn't work fine with the new transistors, then I know that it's not working because of the new transistors and not because there's still a problem somewhere. And that is the beauty of having multiple of the same amplifier to work on. If you run into issues like this, it can actually massively speed up the repair process because they're unlikely to have the same issues, and you can compare readings from one to the other, swap parts from one to the other, and diagnose it much quicker. Sometimes in the past, actually, I think on 1 or 2 occasions when I was learning amplifier repair sort of thing, I got an amplifier in that I was really struggling with, and I literally bought a fully working one of the same model just to run some readings from and stuff, and to swap parts out of to fix the dead one, and it works a treat. So okay, what should we do then? I think what should we do? I'm tempted to just power it up one more time. Now that I've removed this short to ground that I made, I'm going to power it up one more time. I'm just going to take some readings of those transistors with my scope. I don't think I'm going to be able to pinpoint the issue like this, but I'm tempted to see whether I can. When you have DC offset issues like this on the drive, you won't just get that reading on the transistor that's bad. It will be on all of them, and it's very difficult to try and figure out where the problem is coming from. But maybe I can kind of get a rough idea by just probing them and pinpointing it down that way. So let's power it back on and let's get that DC. Here we go. There's that DC, you can see it here. I've got about 22 volts on there. So I'm going to go ahead and probe some of these drive transistors now, just to see whether the issue is easy to spot. So up here we're looking for a voltage that is like the same as what the DC we've got on the source. So the DC we've got on the source that shouldn't be there is sitting at 20 volts on the scope right here. Okay, so that's the voltage that we're looking to see on any of these transistors. So that there is positive rail, 44 volts, that's fine. That there is 45 volts with the drive wave on it, that's going to be fine. That there is 22.4, so that there is the issue. So there's the DC that shouldn't be there, so it's possible that this transistor is leaking. So I'm going to mark this transistor as potentially bad. Let's go back to this one. Let's take a look. So this one we have drive sitting at ground, drive sitting on positive rail, and positive rail. So that one's probably okay. Let's go along. We've got drive sitting at ground, we've got drive sitting around ground, ground itself, and that's the low side. So that's not going to be the issue because the issue is on the high side. Drive on ground, high, nothing. Drive on ground, high, drive. Just going along these and looking for the 22 volts that shouldn't be there. 46, 46, 40, 45. This transistor has pretty much positive rail voltage on every single pin. 46. Ah! Hey. Remember that capacitor? Remember that capacitor that we looked at before that was like rusty as frick? Well, something's telling me that maybe that is actually the problem, even though I was like, that's probably not going to be the problem. So the reason that I think maybe that is the case is that capacitor that kind of looks janky is these pins here. If I zoom right in, that janky capacitor that we saw earlier is these two pins here. So usually, okay, the reason for a capacitor is to like smooth voltages or something. So usually with a capacitor, you'll find on one leg of it you'll have like a voltage, and on the other leg you'll have either ground or a negative voltage or something considerably lower. So you'll usually have like a decent amount of voltage across a capacitor. In this case, on one side of the capacitor we've got 46.3 volts. That is positive rail voltage. On the other side of the capacitor we've got 45.6. So across this capacitor there is only about 0.8 of a volt, which doesn't really check out. Like, you wouldn't usually see that. So it's very possible that this capacitor is actually just like a high value resistor now and it's leaking voltage between it. Let's go ahead and just check another capacitor just to show you what I mean. So there's another capacitor down here which is a 25 volt 47 UF. So this one has some drive on it, okay? This one's like a drive. Yeah, here we go. This one has the audio wave on it. So that one's going to be right. That's a low voltage capacitor. I'm looking for one like a 50 volt. Here we go. There's a 50 volt one down here. Yeah, there's another 50 volt one down here. I just want to see what's on this one. So on this one we have, here we go, negative rail, 37 volts. And on the other pin we have 32 volts. So that's going to be like, I don't know. But like that's a bit of, that's a decent voltage drop. So the first thing that makes sense then is to remove that stanky looking capacitor, whack it on the ESR meter, just see what it reads. See what it reads. If it reads a high resistance only and like no capacitance, then obviously that's going to be the issue. And we can also power the amplifier up with the capacitor removed and see if the DC voltage has gone away. That's another thing we can do. So let's do that first, because that is the janky looking thing. And that janky looking capacitor, if you weren't there on the stream earlier, the janky looking capacitor looks like this. I turn the light off, you can maybe see it a bit better. Looks a bit rusted around there, you know what I mean? So that's the one that we were removing just now. Alright, so we're going to throw this in our ESR tester. This is going to read the capacitance of this bad boy, see if it's actually what it's supposed to be or not. Let's take a look. Okay. This is supposed to be a 10 UF, 10 microfarad capacitor, and on the screen here it shows, I don't know if this is going to do a focus, this camera, there we go, always backwards, we show this one. So here we go, this is reading as roughly 10,000 nanofarads, which is 10 UF. ESR is a little high, but I don't particularly trust this this meter for measuring ESR accurately. 1.3 ohms, it's probably like test lead resistance. So actually that's possibly okay. I'm just going to power the amplifier up with this removed just to confirm, but I imagine the DC voltage is still going to be there. Yep, still there. So the janky looking capacitor, not so janky after all. Probably just a bit of old like solder flux or like glue or something. I'll probably change that anyway, but for now let's just throw it back in just for now. I'm going to dig through my capacitor set and look for the same one just now. So let's throw that back in real quick. Which way around? Oh, there we go, that way round, negative that way. So yeah, I think that there was bad DC on this capacitor just by chance of the fault that is actually elsewhere on the board. I don't think that there should be only 0.8 of a voltage drop across this capacitor, but I think the issue causing that is somewhere else. There we go, that's back in there now. So I noticed that there was dodgy looking voltages on this transistor. This was the first one I tested over here, this one here. And this one looked like it had some, it had the 22 volts on it. This one had the 22 volts on it, and a lot of the other ones didn't. So I'm just going to go ahead and check some of these other transistors down on the bottom here, and just to see whether the voltage appears on any of those. So that's rail voltage. Here we go, 22 volts. So yeah, actually the 22 volts is appearing on some of these bad boys down here. So I reckon the issue is these bad boys down here in the middle. Well, there we go. There's our 20. Now, if you think about it, okay, the DC voltage that we're seeing where we shouldn't is positive, okay? So if we've got a leaking transistor, then the transistor that it's going to be will probably have rail voltage on one of its pins and like positive rail voltage on one of its pins and drive on the other, because it's the leak we've got is a positive voltage, okay? So it's going to be leaking from the positive rail. So the transistor that we're looking for is going to be one that has positive rail on one of its legs, like for example this one here. See that's got positive rail, and then on some of these other ones over here, it's got the drive with the positive, with like half of the positive rail on it. That's a low side one, so that's going to be alright, that's not going to be the issue. So it looks like we've got 4 transistors, 1, 2, 3, 4, dealing with the low drive. And we've got 1, 2, 3, 4 here dealing with the high drive. So those 4 transistors are going to be the ones that we're going to be wanting to change to get this back up and running. Yeah, Jim, we're gonna change the capacitor anyway, but I've just thrown it back in because it's reading roughly the right thing for now, and it's not the issue here. But I'll probably change it anyway. Alright then, let's get to removing the driver card. It should be fairly easy on these amplifiers. There's not much glue. Actually, I don't think there's any glue holding this in place. So, easiest way to remove these driver cards is just to take a soldering iron nice and hot and just proper soak the pins all along here. Probably get them soaked up. A bunch of new fresh solder on there. Keep it all hot, and then it should just pull out. You can suck the solder from the individual pins, but I'm not sure if I can be bothered to do that. Maybe I'll do that. Let's see how this goes first. It's easier to keep this straight as well, rather than sinking down like that. There we go. I'm just going to flood all of these pins here with fresh solder. Get some flux going on in there as well. Run it back and forward a bunch of times, and then they should all melt and stay hot enough for me to pull the driver board out. Provided there's not any glue on the top, which I don't think there is. That should be coming out now. Maybe there's some glue. Might have just been quicker to suck the holes independently, actually. I think I would usually just suck the holes, but I think for some reason tonight I fancy doing it this way. There we go. Out you come. There we go. That's most of the pins out this side. Let's go get the other side. There we go. And she's out. So a closer look at this driver board then, because it's been a little bit tricky to see it in detail. So which ones were the low side? Look, ow, that's still very, very hot. Let's go over here. So the low side ones were closer to this end. So if we just sort of hold that back up. So the low side drive transistors are going to be these ones along here, 1, 2, 3, 4. And the high side one's going to be 1, 2, 3, 4. So it's going to be one of these high side ones that's the bad one, because we've got high rail. So these are MPSA 56 and probably 42. MSPA 56, A42, A42. So I think I have a bunch of spare ones of these. So that should be pretty easy to just swap right out. Yay! One, two, three, four. So what I'm actually going to do is I'm going to use a clip, a little bulldog clip, to strap this driver board down to the desk. Makes life a lot easier, I think. How do I usually do this? Because this is such a tiny driver card, I need I need access to both sides, and I need it to stay put. So we're looking at these ones over this side. One's closest to the middle of the board, so if I clip the driver board to here like this, just lay those capacitors down. There we go. Now I can. Now it doesn't move around all over the place. You see, tiny little driver board like this, it likes to get free when you're doing work like this. Okay, so let's zoom in a little bit over here. So yep, let's remove these ones. So what I actually need to just double check is which ones go where. So I think the 42s go closest to the chip. So just remember that, guys, in case I forget. The 42s go closest to the chip. I'm hoping they're just going to fall right out. Oh, there we go, they just fall straight out of there. Don't even have to pull from the other side. Okay, there's a couple there that didn't fall out, but we've pushed them through, so we should be able to get them out from the top. There we go, nice and easy. That was a 42. And the 56 is. So yeah, it's crazy to think that those drive chips have all this stuff pretty much just chilling inside the chip, inside the integrated circuit. And let's just suck the solder from those holes real quick. So I actually get quite a lot of questions about my solder sucker here. So people say they haven't seen one of these before with the silicon tip. So they don't make them with the silicon tip, not that I've really seen anyway. I just take a silicon tip that comes with my soldering iron tip. So my soldering iron tips come with a little bit of silicon on the end of them here, just like protective, and it fits beautifully on the end of my solder sucker. You could buy silicon hose that's the right diameter and just cut it to size, and I honestly find that this makes these little cheap suckers work so much better. It makes an airtight seal around the area that you're working on every time, and I would not be without it now. I have tried using the desoldering guns and stuff in the past, and while some of them are pretty good, I find that more time is spent cleaning them out than actually, you know, benefiting from their speed of use. So really, just the old school manual sucker is actually the quickest, most efficient way for me. There we go, and we just got a bit of solder blob on the top to deal with. One stubborn boy here. There we go. There we go. Okay. Give it a brush off. Make sure we didn't make any solder bridges. Always important to check. No matter how much soldering you do, there's always chances of making bridges. Very easy to do. Alright, cool. Now, out of interest, those parts removed, I think that one of these is going to be bad. One of them fell on the floor, so hopefully the one that fell on the floor isn't the one that's bad. I'm going to go ahead and check these in my transistor tester and just see if I have found the bad component. Let's check the first one. This is a 56. So the first one, we've got a correct part reading. That's fine. PNP, HFE 160. Let's check the next 56. If all of these are fine, that's going to be really annoying because that means that we haven't found the issue. That one's alright. Check 42. Ah, butts. So it's either the one that fell on the floor or it's not. This isn't the issue. Can I quickly see it? Can I easily see the one on the floor? With my torch. Here it is, found it I think. Yep, this is the one. Come on. Ah! Damn it! Let's put these transistors to one side because it might still be one of those. Like, I have had a rare occasion sometimes when the transistor tester has said they're fine, but they are still leaking. So let's just suck the holes from the driver board pads here, and I'm going to hold the driver board back in place and see if I can see where the DC is coming from with these ones out. So these ones are like the pre-drivers or the main driver. I think these are the main drivers. So let's just put this back in here temporarily. I'm not going to solder it back in. I'm just going to hold it back in. Suck the holes real quick. This is another reason. So how long have I spent on this amplifier? So the stream has been getting on for 1 hour 41, but I wasn't doing this amplifier for the whole stream. I did some chatting, but I probably worked on this amplifier now. If I wasn't streaming, this would be getting on for about half an hour, 45 minutes, which is already putting the the repair bill at more than this amplifier is worth. But you guys want to see it because it's a it's a slightly interesting one. It's a different issue than some of the stuff we see before. So what the hell? Why not? How's the stream, by the way? Is it working nicely now? Should be working pretty good. Hopefully no more dropouts and stuttering. Okay, sweet. I think we're all good there. Okay, so let's hold the driver board back in place. Now this isn't a problem because we don't have any FETs in the board. Let's just clean up these pins a little bit on the driver board. Got some big solder blobby boys. Let's get rid of those so that it slides nicely back in. Okay, there we go. I think that's in nicely. Yep, there we go, that's in nicely. So, now let's power it back up. I'm going to have to hold the driver board in at an angle just to ensure that all of these pins are making a good contact against the pads there. And I'm just going to be looking for that 22 volts that shouldn't be there. And it should appear somewhere else on the board, on the driver board, and then we can go looking for parts to replace over there. So let's get some power, get some remote going in. Okay, back to checking for the voltages. So I'm going to push on the driver card like this. Hopefully that doesn't get in the way too much of the camera. And hopefully that's enough to make a contact on all those pins temporarily. Ah, there we go, look, 18, 19 volts is still there. Okay, let's have a look then. No, maybe it was my first guess with this bad boy up here. Okay, so the next one I'm going to replace is this bad boy up here. I'm going to do them one at a time now. So there's a transistor up the top here, which was actually the first one that I tested. And that one has the 22 volts on it. So I'm going to go ahead and check that one. I'm going to take it out and see what the jam is on this one. Can I clamp my can I clamp it onto there like that? Come on. Yeah, kinda. Just trying to get it held up nicely. Oh, there we go. I can clamp it probably onto there, maybe. Stay still. The camera's moving around. I need one of those helping hands tools that you can get for soldering. usually driver boards are all surface mount that I work on, so I'm not used to like these tiny ass boards just flying around all over the place. There we go. Okay, so please be bad. Please be a bad boy. That's a very hot, very spicy boy. Ow, ow, ow. Hot, hot, hot. That is an A92, so that is a different transistor again. Ah, that one's reading correct. Okay, so that A92 goes there. So that one's not the problem. Back in the board we go, and looking for the voltage again. Hey, it's different now though. It's different now though. Maybe it's because I wasn't putting enough pressure on this. So now it's kind of different. It's kind of just glitching. So positive, positive. That's interesting. That's interesting. The DC has gone away from that area there, but is it still on the high side? That's interesting. So the DC has actually gone away now. Although it kind of looked like it kind of appeared a little bit at the start. Let's have a look. So yeah, the DC has actually gone away now, so maybe that one, it was leaking. I'm going to go ahead and probe back to those original drive transistors that we removed earlier. There's nothing on these now. So either this one that I've just removed is like supplying voltage to another bad component, or that one is the one that itself is bad. Okay, so that was an A92, so I'm going to go ahead and throw another A92 in there and see whether the DC comes back where it shouldn't be. Because at the moment it seems to have disappeared. Yep, the DC has left the building. We just have all the correct voltages now by the looks of things. Just checking in case I'm missing where the bad voltage is anywhere. There's one more transistor that doesn't quite look right, and that is this big boy right here. This has 46, 46 and 45 on it. It's like a kind of 1 volt difference. So I'm going to pull that one, and I'm just, if that one reads okay, I'm going to change the A92 that I just removed and go from there. This transistor is the one that's closest to that stanky looking capacitor that we saw earlier. There we go, that was quickly out. And this is an A1013. So let's see. That one reads okay as well. Alright, sweet. So let's change the A92 on this driver board and see if the voltage comes back or not. What do you reckon, guys? Do you want me to get to the end of this one? I mean, this one has gone on way long. Very unusual to get a drive circuit fault on these little plate amplifiers. Usually it's, like I say, a very simple fault. But would you like me to get to the end of it? Or would you like me to move on to another one and see some more common faults with these things? Let me know what you would like to see. Once we get to the end of this, well, actually, to be fair, I think actually it's going to be time to end the stream anyway. So either replacing this works, or we're going to have to probably call it a day for this evening. It's getting pretty late here. It's a shame because I named this stream how many small amplifiers can we get through in one stream, and here the answer is either going to be 1 or 0, just because the first one was like a bit of a biatch. I hate these tiny driver cards. They just they fly around all over the place. I need it to be like, stay still, damn it. Stay still. There we go. Finally. Right. Holes are empty on that one. Cool. I think that 1013 transistor got knocked off by this flying around. That's really freaking annoying. So I'm going to have to nick one from another board temporarily. Alright, so this was the A92 transistor that when I removed it, the DC voltage seemed to go away. So let's just, because I can't bother to dig through all my transistors up here at the moment, unless I've got one real quick. I might just nick one from another one of these amplifiers just to confirm, but I'm just going to look through my, I've got Class AB old driver, here we go. Got a little pot here called old drivers, so I'm just going to see if I've got an A92 in here somewhere. If I see it within the next like 30 seconds, then I'll use it, otherwise I'll just nick one from another board. Oh, A92, would you look at that? Oh no, the transistor hadn't fallen out of the table, it was actually just still in here. That's good to know, that's good to know. So let's just check this A92 that I've just found in my spare parts drawer, make sure that this one reads alright. Yep, that one seems to read okay. So let's go ahead and drop these back in and see if the DC voltage has gone away or is still there. First of all, just need to suck the solder from the holes of the A92 location, which is just here. Come on. This is the most frustrating thing, sucking the holes from like these driver boards, I'll tell you. Need it to stay still. Maybe some blue tack on the bench. That's one. Two. Three. There we go. Okay, so A92. I think this is the good one, and this is the bad one. Yep. You go in there just like that. He's got a bent leg, so I'm just going to straighten up his leg. You go in there, and just a dab of solder to keep you in. Put this big boy back in. Okay, cool. Now I'm going to pray. I'm going to pray for the good Lord above that the DC has disappeared. If the DC comes back now that I've fitted the new A92, then it just proves to me that the A92 is just supplying, like, is activating another part of the circuit which has the faulty component in it instead. What do you reckon, guys? Is it going to be there, or is it going to be, or is it going to have fixed itself now that we've? Has the A92 that I've just changed? Is that the issue? Has that resolved it? What do you reckon? Do you reckon the DC is still going to be there? Man, thanks for the 20, Seth Tyrant. What time is it? Your neck of the woods, Sam? It is 1:23 a.m. So it's getting towards the end of the stream. I don't want to be streaming past 1:30 a.m. So either this fixes it, and that's great news, or it doesn't and we call it a day and we have 0 repaired amplifiers in this live stream. And a 10 from Jeff Burrows. Thank you so much, man. Massively appreciated. That's really, really, really generous of you. Really, really generous. Thank you very much, man. That's awesome. So Nikki thinks it's going to be still there. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Get rid of that little solder bridge before I hit go. And go. $45. Oh, guys. Hey, wait a minute. Wait a minute. Ah, stankin' dead. What the frick? 26. Really? It's still there. It's, what the hell? It's now on all of these. What the heck? It's still there, guys. It's still there. What the hell? It's not on this A92 anymore. But it's now down here, 26.4. And it's still on this, it's still on the high side source. Where is this coming from? Alright, I'm going to take a slightly different approach. Just before I lock the stream off, I'm going to take a slightly different approach. I'm going to check to see which pin the 26.5 volts is on, and then I'm going to trace up from there and find. So we've got plus 15 volts. That's going to be an auxiliary rail. Minus 15 volts. That's not a problem. So positive rail, 26. So we've got on a whole bunch of these actually. Maybe it's coming from the board. Actually, I hadn't considered that. Maybe it's coming from the board. Let's remove the driver card and just make sure that that isn't coming from the board instead of the driver card. So we got negative. Well, we got negative rail on that one. Yep. Negative rail on that one. Nothing on that one. Nothing on that one. P out. Nothing on that one. Positive rail there. Switch, nothing on that one. Minus 15, positive 15, nothing on there. N negative, nothing on there. N positive, that's where the audio is coming in. Okay, so the issue is on the driver board then, because yeah, it's not there when we take the driver board out. Okay, the issue is on the driver board. Can I just really quickly find where it is? What the hell? What the hell? So if it's on these ones down here, potentially there's a diode right here. Hey, there's a couple of diodes. Generally, the components to fail first will be semiconductor parts, so like diodes, transistors, MOSFETs, that kind of thing. So I'm always going to be looking at diodes and crap first, before like capacitors and resistors and stuff. So okay, that has drive. That has drive on it, that little diode there. I think there's another diode just over here, one after the chip, just here. That has the audio on it, and on the other side it has the bottom half of the audio wave. I think that's meant to be there probably. That has 22 volts on it. That has 46, that has 46, that has 45. It's back on the A92 that I fitted. It's not on any of these ones because these are low side drive. This is the chip that's generating the class D switching based on the audio signal input, and a triangle wave and a square wave, so that's not the issue. Maybe it's one of these capacitors over this side. Here we go, there's a bunch of capacitors over here, like little ones. 3 volts there, 27, there's 27 volts on that capacitor. Negative 15. I just can't figure out where it's coming from, guys. Could also be the board itself. Like occasionally these PCBs will go conductive because they run really hot, so the actual leaking could just be coming through the PCB. That is also a possibility, in between one of these driver holes. I have had that issue before. Doesn't show any massive signs of like getting crazy hot or anything though. There's a little diode down here that I didn't check. that's where it is. It's right there. It's right there. That should not be there, bruh. It's there, but it's not there. It's not there. And it's on all of these empty pads. And it's on this capacitor, but the other side of that capacitor isn't. So that capacitor's not leaking. So I've changed this one. These high side ones are removed, and that's where the voltage is sitting. The 22 volts is on this A92 transistor. It's not on any of these three. It's not on this capacitor. It's not on any of these diodes over here. It's not on any of these capacitors over here either. So this is a proper strange one. I actually think that the voltage is leaking through the PCB. So I don't think that that's a fix. I think that that is a throwaway. Mad. Alright. So I guess that is the end of that. I think the issue is that the PCB is leaking. And the way to confirm that would be to literally take like all the parts off of the PCB here, swap them out for one of these other ones that work, and confirm that. But ain't nobody got time for that. So, oh shit, I'm really sorry guys, this has been a bit of a crappy live stream because I was hoping to literally bang through a bunch of these plate amplifiers here. Really simple issues, cracked solder joints on the TL494, on the wires coming in, the transformer shorting out, MOSFETs blown, easy replace. I was going to bang through them for you guys and show you some simple issues. However, I ended up diving into old janky discrete class D driver circuit repair that appears to be non-repairable, appears to be leaking voltage through the PCB. I have seen this once or twice on these before. Sometimes you can see, if you hold the board up to light, you can kind of see through the PCB for dark spots where it's leaking, but this PCB here is a little too thick for that, and it's like, I think that's a little too thick for this. Is not. I can't really shine the light through it properly to see. So yeah, sorry guys, but hopefully it was entertaining for you, and it was a nice little test stream to make sure that the streaming is working again, so I can now do this in the future and not have to worry about the stream dropping out. I think it's stayed pretty stable since I made the changes I made earlier, so just let me know if there was any major issues you found with the stream. I'm just going to quickly look through the live chat real quick before we head off. Yeah, it's really annoying. Like literally, any other day I would sit here and just like finish this up. But I'm really tired. I want to hit the bed. So, but I'm tempted to come back to this maybe tomorrow or something during the day, and then potentially what I might do is tomorrow or over the next couple of days I'll do another stream just like this where we revisit the other ones that should be hopefully easier than this one, and try and do this stream again as I intended it to be. And if I have any updates on this really pesky one, I'll let you know what the actual issue ended up being. But yeah, thanks so much for sticking with me on the stream, guys. Thanks for helping me test out that the stream was working alright. I'm going to keep back up with the streams regularly. Going to try and do sort of 2 or 3 a week at least. Get some interesting info back for you guys. Get some repairs going. Be entertaining, you know. Yeah. Should be all good. Snap it in half. Yeah, it is tempting, but I want to find the issue for future reference, you know. I want to find the issue for future reference. And the way that I'm going to find the issue is by legit taking all of the transistors off and all of the semiconductor components off of this board and looking for the DC voltage that way, and swapping them out for one that works and trying to find where the issue is. I think the board is conductive. I honestly do, because these do run hot. when are we going to see your van again? You'll see my van again when the subs are fitted back in. I've taken the subs out to make some changes to the box, the port, changing the port a little bit, and I'm mounting the subs the other way around. I don't like the DDZs inverted because they have quite a lot of motor noise where there's no pole vent, so all the air that's forced down through the coil and around the former, it chuffs, and it's audible because they're inverted behind my head. So I'm going to spin them around, listen to the nice cones on the DDZs. That's the way it should be, but I need to have some rings made, so that's all happening over the next couple of weeks. So 23rd, after 23rd it should be done, so you should get to see more of the van probably coming up in the April, May months. I'll do an update video of the van and show you what I've got going on in that then. But yeah, until then guys, thank you very much for sticking with me on the stream. It's been awesome to be back, and yeah, I'll catch you all next time. Thanks again to everyone who sent in donations. Massively awesome, very, very generous of you guys. Seth, Jeff, there was a couple of guys up here. I'm not sure how far this lets me scroll. Elliot, thank you very much for the donations, and that's as high as I can go. But yeah, all your donations are massively appreciated. I never done this expecting for people to be sending cash my way, but no, it's pretty crazy. And actually interesting, if you're new to the stream and you weren't following me back in the day, my bench power supply right here, which is this bad boy, this EPS power supply, that was funded by you guys with your donations on the stream. Literally, I had a little fundraiser to get me a decent bench power supply because I was running like these little shitty like switching power supplies at the time. And yeah, donations came in strong and hooked me up with a bench power supply that is hopefully being good for you guys because it lets you see the current drawn and the voltage on the power supply. So thank you so much for that, massively appreciate it, and I use it literally every day. I'm in the workshop and I'm using this power supply, and it reminds me of the generosity and kindness of you guys watching me on the stream. So thank you very much again. DD coils have ventilation. The DDZs have no pole vent. So yeah, basically the air chuffs out through the coil, which is fine. It's not an issue. It's actually good. It's good for cooling, but it does mean that you do hear the air chuffing around the coil if it's inverted. Yeah, cool. I'll chat to you next time then, guys. It'll either be, what day is it now? Like freaking Saturday now, so it'll either be like maybe over the weekend or Monday that I see you next, and I'll give you an update on these amplifiers that we're working on. We've also got an LW Audio 4.5K Class D Korean half bridge to work on as well, so you'll see that soon. Once again, thanks guys, see you next time, and hopefully I can do the outro nice and smooth, and I have to go like this. Yeah, there we go.